Hi friends, I'm Mrs. Gradney, and today we'll be investigating and using the formulas for area and perimeter of rectangles. Here's what you'll need for our lesson. Let's get started. On our grid paper, each square represents 1 unit. Pause the video and draw a rectangle that's 4 units wide and 7 units long and label the side lengths. Welcome back. Does your rectangle look like mine? You may have also drawn your rectangle going the other way. So 4 units going down and 7 units across, and that would be okay too. We typically call the longer side of a rectangle the length and the shorter side the width, but it really doesn't matter. If I were to say that this rectangle was 4 units long and 7 units wide, that would also be correct. Now, what do you notice about this rectangle? Pause the video to say what you notice. You may have noticed that the opposite sides of the rectangle are the same length. So this side is 4 units long, and the opposite side is 4 units long. This side is 7 units long, and the opposite side is 7 units long. You may have also noticed that the rectangle has 4 right angles. Great noticing. Now, I want you to grab your pencil, and I'm going to use a highlighter so that we can really see it on the screen. And I want you to put your pencil on any one of the corners of the rectangle. I'm going to put mine here, and we're going to trace around the outside of the rectangle until we get back to where we started. Okay, let's do it. We just traced around the outside of the rectangle. Think back to what you learned in 3rd grade. What do we call the measurement of the distance around a rectangle? We call the distance around a rectangle the perimeter. Everyone say perimeter. Now I want you to pause the video again, and this time I want you to trace the perimeter again, but this time count the units as you trace them so that you can find the perimeter. And then come back when you're ready to compare the perimeter you got with the perimeter I got. Welcome back. So did you find the perimeter by counting all of the units around the rectangle? I did too. I got that the perimeter is 22 units. What did you get? We can write P equals 22 units. And of course, what do you think that P stands for? Right, perimeter. Now, when we know the measurements of the length and the width of a rectangle, is there a quicker way we could find the perimeter rather than having to count all of the units around the outside? When we know the measurements of the length and the width of a rectangle, we could find the perimeter by adding the length of all 4 sides together. Great thinking. Now, I want you to pause the video again. And this time, I want you to count all of the squares inside the rectangle. So what'd you get? I got 28 square units. When we counted all of the squares inside the rectangle, think back to what you learned in 3rd grade. What measurement did we find? We found the area. Everyone say area. And we can write A equals 28 square units. And of course, the A stands for area, right? Now, how come this time, when we measured the area, we had to write square units, whereas when we measured the perimeter, we just had to write units? Why is that? When we measured the area, we had to write square units because we measure area with square units. We actually had to count all of the squares inside the rectangle. Now, what do you remember from 3rd grade about how to find the area of a rectangle? Maybe you remember that we can count all of the squares inside a rectangle like we just did. Or maybe you remember that we can also find the area by multiplying the length times the width of the rectangle. So 7 units times 4 units equals 28 square units. Now pause the video again and draw a new rectangle that's 3 units wide and 9 units long, and label the side lengths. Welcome back. Here's my rectangle. Does yours look the same? Now, how could we find the perimeter of this rectangle? Pause the video to talk out your thinking. You may have said that to find the perimeter, we could count all of the units around the outside of the rectangle like we did earlier. Or maybe you remembered that we talked about adding all 4 side lengths together to find the perimeter. So 9 plus 3 plus 9 plus 3 equals 24 units. So the perimeter is 24 units. Now let me record what we just said. We said that to find the perimeter, we could add 9 plus 3 plus 9 plus 3. That's the length plus the width plus the length plus the width. So to find the perimeter, we could do length plus width plus length plus width. Now I'm writing these L's a little bit funny so that we don't get them confused with a number 1, but they're really just lowercase L's. Now, since we can add in any order, we could also add 9 plus 9 plus 3 plus 3. We can see that we have 2 lengths and 2 widths. That would be like doubling the length and doubling the width instead of adding all 4 sides together. We can see in this equation that we also have 2 lengths and 2 widths. So double 9 is 18, and double 3 is 6, and 18 plus 6 equals 24. So the perimeter is still 24 units, even if we find it that different way. So let me record what we just said. To find the perimeter, we could also find double the length, or 2 times the length, plus double the width, or 2 times the width. Now let's trace along 1 length and 1 width of the rectangle. How many units did we trace? We traced 12 units. How does 12 relate to the length and the width of the rectangle? 12 is the sum of the length and the width. 9 plus 3 equals 12. So how does the sum of the length and the width of the rectangle relate to the perimeter of the whole rectangle? Pause the video to talk out your thinking. You may have noticed that the sum of the length and the width is halfway around the whole rectangle, so it would be half of the perimeter. So another way we could think about finding the perimeter would be to add the length and the width and then double that sum. Let me record this thinking. To find the perimeter, we could add the length and the width and then double that sum, or find 2 times that sum. What I just recorded were formulas for perimeter. Let's use this last formula here now to find the perimeter of this rectangle. So to use this formula, we will be finding 2 times the length plus the width, so 9 plus 3. What is the length plus the width of this rectangle? It's 12. So 2 times 12, double 12 units, or 2 times 12 units equals 24 units, which is what we found here. Now let's put that grid paper away for a little bit, but keep it close by because we'll be looking at those rectangles again in a little bit. And right now we just need our whiteboards. Let's draw a rectangle. And we know that the length of this rectangle is 5 units. And we don't know the width of the rectangle, so let's label that with a variable. And let's say x units. We know the perimeter of this rectangle is 26 units. How might we determine what the width of this rectangle is? Pause the video to think about it and talk out your thinking. There's more than one way that we could think about how to find the width of this rectangle. One way to think about it is that we know opposite sides are the same length. So if this side is 5 units long, then this side is also 5 units long. If we subtract these two lengths from the perimeter, then that will give us the sum of the other two sides. So 26 minus 10 equals 16. So the sum of this side and this side is 16. Since opposite sides are the same length, 8 plus 8 equals 16. Each side must be 8 units long, so x equals 8 units. Another way we could think about it is this. We know that if we add the length and the width of a rectangle, it will give us half of the perimeter. So half of the perimeter of this rectangle, half of 26, is 13. So 5 plus some units equals 13. Well, we know 5 plus 8 equals 13, so x equals 8 units. Let's look back at the rectangle now that we drew on grid paper that had a width of 3 units and a length of 9 units. How can we find the area of this rectangle? Pause the video to talk out your thinking. You may have said we could count all of the squares inside the rectangle to find the area. Or maybe you don't want to have to count all the squares. We could also count the number of squares in one row and then skip count by that number for all the rows, like this. There are 3 squares in one row, so let's skip count by 3s. Ready? 3, 6, 9, 12, 15, 18, 21, 24, 27. So the area equals 27 square units. Notice this time I abbreviated square. Now, can anyone think of a more efficient way to find the area? When we skip counted, that may have reminded you that multiplication is similar to skip counting, but it's more efficient. So we could just multiply 9 times 3 because we have 9 rows of 3. So 9 times 3, and that equals 27 square units. Earlier, we talked about some formulas for perimeter, and we just discovered a formula for area. If we use A for area, L for length, and W for width, how could we write the formula? We could write A equals length times width. Let's go back to our whiteboards now, and let's draw another rectangle. And the area of this rectangle equals 50 square centimeters. The length of the rectangle is 10 centimeters, and we don't know the width. How might we find the width of this rectangle? Pause the video to talk out your thinking. If we use the area formula to find the width, we could think 50 square centimeters is equal to 10 centimeters times whatever the width is. So what times 10 equals 50? 5 times 10 equals 50. So the width equals 5 centimeters. We could also use division to think about this. 50 divided by 10 equals 5. So again, the width is 5 centimeters. Excellent job today, friends. I think we're ready for the problem set. On the screen are the must-do problems for the problem set. Set a timer or watch the clock for 10 minutes and work on these problems. If you have extra time, feel free to try the other problems on the problem set as well. Today, we investigated and used the formulas for area,